Is precast concrete only Lego for adults, or is there a lot more to it? Stick around, and our next guest will untangle all of that. Don't forget to like and subscribe. All right, Chad, welcome to the show.
Thank you. Nice to be here.
Great. So tell us a bit about your backstory. What's your experience in construction?
Well, so I am a degreed civil engineer from a small college in Grand Rapids, Michigan. I actually knew very little about construction when I graduated. I hired on at a precast concrete plant as a quality control engineer right out of college. I worked my way up through the business from quality control to plant engineer and then to a design engineer and project management. And I've pretty much stayed inside the precast concrete construction market my whole career, which right now is about 25 years.
Nice.
So one of the biggest things that kept me here was the what's called PCI, the Prestressed Concrete Institute, which is basically all the precast plants in the United States and Canada and even some in Europe that work together, engineering wise, technically wise, to develop standards and standard construction methods for the industry.
Excellent. So then, tell us a bit about your current role. So it sounds like it relates to that, but also how your experience has influenced your current role.
So right now I am manager of pre-construction for Fabcon, which is a large precast producer across the United States. What we do in pre-construction is we help the AEC community, architects, engineers, and contractors put together their projects in precast. A lot of them aren't very experienced in the product. It's an engineered product. So my role here is to work with salesmen, estimators, and the AEC community to develop projects in precast. I've had backgrounds in quality control, engineering, project management, running a precast plant as well, and having all that background allows me to kind of see multiple areas of where things could go wrong on a project and kind of help steer the design team into a good location for the project.
Excellent. So my background as an MEP engineer, most of the time we saw the tilt-up methods was on industrial applications. So I imagine that's still the case, that's where it's most commonly used. Why don't you tell the audience a bit about the benefits of precast, pre-stress, tilt-up methods? What advantages do they offer to construction?
Well, I think the easiest way to describe precast from a plant cast perspective is Legos for adults, right? We pre-engineer all the components of a building system, core and shell or core and shell with an exterior skin out of precast in our yard. We ship it to the job site and we erect it on site. We can go vertically, we can do warehouses. A lot of it has to do with coordination of the engineering aspect and all the other trades that are involved: mechanical, electrical, plumbing, architectural details, room finish, fire protection. All that stuff has to be coordinated. It's fully customizable, so everything we do is specific to your project. We don't ever mass make a bunch of, say, columns and ship them to job sites. They're all specific to your project. So that's kind of unique with precast and some other building models. For instance, in the steel market, a W8 by 12 is a W8 by 12 no matter where you get it from, but a precast beam could vary widely between precast producers in the same region.
Okay, so have you got examples of where you've converted from steel to cast in place or precast, and what were the success factors in overcoming those challenges?
Yeah, so a lot of what I do in pre-construction is actually that convert stuff that was building material A into precast. We recently completed a 12-story total precast triangular shaped building in downtown Grand Rapids, Michigan. It's a 2022 PCI award winning project. That one came to us because of the difficulties with other structural systems creating hotel rooms that had columns in them, and the owner of the hotel did not want any obstructions in their room. With precast, your span to depth ratio increases. You're allowed to get more clear spans, eliminating columns, and we were able to create the space that the hotel owner needed for their building. Another example, a pool complex in Caledonia, Michigan, where the steel trusses, they were 100 foot long. They were During the crunch and the joists in the market, they weren't readily available for several weeks, and we were able to provide a precast solution for a steel and metal panel building that was total precast. Contractors typically don't look at precast as an option because they think it's concrete, it's going to be more expensive, it's going to be more complex. But a lot of the engineering and design of the product stays with the precast producer like myself. So we engineer all that stuff, all the components, all the connections, all the details, and we work with the engineer to make sure the building performs the way he wants it to perform at the end of the day.
There's also a big shift in the industry towards design build. So maybe just talk us through what is design build and how does precast construction support those approaches?
Yeah, so precast is actually really good for design build because we are so unique and we're specific to everyone's project. So a lot of the projects we get on that are design build, we start with the architect or the engineer reaching out to us saying, hey, I have this project. What do you think about precast for the option? And then as the contractor is folded into the mix, whether the contractor's on the project at the time or not, we work with everybody on the team to decide where precast is right for the project. There's a lot of projects where we have a mix of steel, block, precast, cast in place, just because it makes sense for the structure type and where it's going in the community. So for us, what we like to do is, as a precast industry, is we like to invite that type of collaboration with architects and engineers to get the project going, to look at it with precast. A lot of the stuff we do is BIM, building information modeling. So we do a lot of stuff in 3D Revit, which makes coordination a lot easier with other trades. And then as the project develops and the contractor starts getting involved, we start working with the contractor on logistics, which means crane placement, crane pad, how we're going to put the building together. We have big, heavy pieces, which means we have a big, heavy crane. And there's a lot of coordination that has to happen between us and the contractor to ensure that crane can get around the job site and set all the pieces as it needs to be set.
So if you think about some of the other techniques that are available with construction, why is this better? What are the benefits? Talk us through those.
Well, some of the benefits are for precast insulated walls, as an example, we provide an insulated wall system. So as opposed to a common construction method, which would be CMU block, an insulation layer, air gap, and brick, we can provide that whole system in one panel. So we can embed brick in the face of the precast. We can sandwich insulation between two concrete layers. So we can provide a fully insulated precast composite wall panel in a much thinner space. And that's where precast kind of starts benefiting the construction, where we start combining systems into one system. So you have a structural system that's also an insulated finished wall panel system, if that makes sense. So you can eliminate, say, your interior columns. You could bury your joist or your other precast components directly in the wall, and you don't need a beam and column system. So it provides a little bit extra space on the inside of your building for that. It's also speed, right? If we're designing with the AEC community as the building is coming up through the design stages, through SDs, DDs, and then eventually the permit documents, by the time we go to submit our shops for approval, we've already basically done all the coordination that needs to happen, and we can start fabricating the same time the contractor is starting the site work, meaning the building will be done and sitting in our yard ready to be installed and put together as soon as he needs the precast. He's not waiting for something to happen on the job site, or in the instance of multi-stories, casting, shoring, reshoring, and then vertically going up and waiting for the concrete to cure. We have cured concrete products in our yard ready to go to the job site as soon as he's ready for them.
Excellent. For our audience and our viewers here, it'd be great to hear in the comments below some of the advantages that you think precast construction has on construction sites. So, Chad, I'm thinking about seismic restraints and seismic issues. How do these methods benefit resilience to the construction with pre-stressed concrete and high seismic areas?
So precast in high seismic areas has been a focus of PCI, which is, again, the Precast Concrete Institute, for several years. They have a specific design manual for it. It's PCI MNL 140 and the seismic design of precast concrete. So PCI has focused on getting precast concrete to meet the stringent demands of high seismic areas such as California, Utah, and along the west coast of the United States. PCI did a half-scale building shake test in coordination with NCEES, which is the National Council of Engineers and Surveyors, the NSF, the National Science Foundation, and then University of Arizona, University of California, San Diego, and Lehigh University. So what they did is they basically tested a precast seismic building, tested all the connections to see how it would behave. So there's an enormous amount of time and effort and dollars being put in to confirm connections that are used in precast concrete in high seismic areas actually will meet the demand when an event occurs. And so this allows the precast producers in those regions to go back to this testing data and these reports and provide the information to building inspectors and officials saying, hey, we've tested this out. We know this is going to work in an earthquake. The benefits of precast in an earthquake area are also in the fabrication. Because we have a certification system, the PCI quality control, and we're inspected by a third-party inspector to ensure we comply with all the quality control measures. We actually are allowed to use less reinforcement in precast than you would in cast in place on site. So it reduces congestion in the bars. It makes the fabrication of the precast pieces a little easier than they would be on site. And similar fashion, it's going to speed up your construction in high seismic areas because the pieces are prefabricated off-site and installed on-site.
Excellent. Would love to have seen that shake test. I know back in my fire engineering days, we did a foam suppression system in an aircraft hangar, and it filled up the bottom of the entire hangar. So it's really good to see the system's actually working.
Yep, that is available online. If you Google the PCI shake table test, it'll show up online and you can watch the whole thing.
Cool.
It's pretty impressive.
Nice. So what about the benefits of these hybrid and composite steel framing systems? How does that enhance the structural integrity and the durability?
So really interesting is that these hybrid framing systems are really popular in Canada and Europe, and they're not so popular here in the United States yet. They're starting to pick up in the United States. It's a great way to compete with cast in place, post tension, or cast in place conventionally reinforced slab systems for vertical high-rise construction. It eliminates shoring. It's a fire-rated system, and it uses, again, a totally 100% prefabricated, pre-engineered structural system that gets shipped to the job site and installed. They're kind of new to the United States, which is why I think they're kind of lagging behind the acceptability on construction sites, and cast in place is still predominant inside the engineering community for vertical construction. But it uses three of the best materials for building, most popular building materials, right? You've got precast steel and cast in place in the hybrid system, and they're all being maximized based on where they're being placed in the system. So it's a really efficient overall construction method that benefits the end user because they maximize the efficiency of all three of those materials.
Got it. Now, FRP is a fiber reinforced polymer, is that right?
Yep.
So what are the benefits of those? How does that all work? Let our audience know a bit more about that.
Yep. So there's several different kinds of FRP. Just recently, ACI 440 just codified the use of glass fiber reinforced bars in concrete. So previously, you could use them inside your concrete structure, but you couldn't use them for primary reinforcing because they weren't approved by the building code yet. That's changed for glass fiber. There's also carbon fiber, and there's also armid fiber. Those fibers are being used now, but again, they can't be used for primary reinforcing. There is also carbon fiber pre-stressing strands that are used in bridges. The DOTs have approved their use in bridges, and they're all used to prevent corrosion. When rebar corrodes and oxygen hits the rebar, they actually expand. When they expand, they crack the concrete, and they allow more water to get into the rebar. It corrodes more, and slowly it just progresses to deteriorating the concrete. This does not happen with FRP rebar. So even if the water does get to the rebar, the corrosion level is so low, it's not detrimental to the structure.
Got it.
DOTs are using a lot of FRP bars right now in bridge beams, and especially along the coast of the United States where there's corrosive environments like salt water and brine water that really make concrete structures difficult to maintain.
Okay, so Is that the future? Is it about the materials? What are you excited about in terms of technology and advancements within your
Yes,
realm?
so yeah, FRP is definitely one that's coming up and really popular. The other thing is ultra high performance concrete. This is 30,000 plus psi concrete. That's it's kind of starting to hit the market now. It's gone through a lot of testing. They're actually starting to use projects on it. It's a little bit hard to control right now, just because we don't have the technology to make large batches of it and pour large concrete forms with it. But there are several producers that are using it, and it's a very interesting material. I don't know if you know what that moon sand is. You kind of take that moon sand and you can shape it to whatever you
Oh
want.
yeah,
It's a
yeah,
kid's toy, right?
yeah.
It looks like that when it comes out of the mixer, and it kind of shapes like that when it comes out of the mixer. But it is at 30,000 psi. It's an amazingly strong material that I
That's
think
crazy.
eventually will pick up and do a lot of benefit for the industry.
Amazing. Sounds pretty interesting. So thinking about project management and best practices now. So if you're pursuing a large building design or precast construction, what are some of the big milestones, the key steps in considering how to have a successful project? What are the subcontractor scope reviews and coordination, things like that, project management wise?
Yep. So typically, what happens is we enter into a design contract first. If we're a large design build project, we'll be brought on as part of the AEC team, and we'll work directly with the architect and engineer and owner to develop their project as an equal team member. That scope is pretty general, as it's just design related. And then what we do is we change order into, or would receive a separate contract for the actual supply of materials, fabrication of the precast, and erection of the precast. So it kind of breaks it up. It also allows the contractor, especially if it's a public job, to bid the project out to multiple precasters without locking himself into one in the design phase. For scope review and for contractors looking at getting into a large design build project, I would recommend that they reach out and choose a couple of precasters that they prefer to work with before they get too far into it.
Mm.
Each precaster is different regionally based on what they can and can't produce, size of beams, size of hollow core, size of double T's. All that changes regionally across multiple producers. So if you get involved with the precaster sooner than later, you'll have a better chance of making sure they can meet your project goals. Scope wise and scope review wise, most precasters are pretty good about telling you what they need and what you need to provide as a contractor. So being involved in those discussions and making sure those discussions carry over from the guy that's negotiating it to the team that's on site really helps. There seems to be sometimes some difficulty in making sure that scope conversation goes from the office to the field smoothly. The other thing is to make sure that as a PM or a contractor, you're really paying attention to logistics on site. The equipment we need to set this stuff is big, it's complex. It comes with a lot of OSHA standards that we have to comply with, and your site has to be prepped and ready for that equipment to show up on site.
Yeah, it's key to get in early because there's such a follow-on effect to all of the other disciplines from engineering all the way through to drywallers when you're making changes. So, yeah,
Yep.
I would encourage that getting in early.
Yep.
I'm thinking about best practices. So when you're engaging the manufacturers, you're coordinating drawings, and you're integrating these precast elements. What are the best practices that make a successful design and build?
Well, the first thing I would say is BIM. We are most successful when we're involved with a team that's very savvy with BIM. It allows a lot of the coordination to happen across multiple trades very fast. It allows for quick problem solving prior to trying to solve those issues on the job site. So if you can get that program up and running and integrate it with your precast team, it'd make your life a lot easier as you go into the fabrication and installation. So there's a couple different things as well. Architectural precast is the pretty stuff on the outside of the building, and there's a very defined step in how you approve those finishes, right? So maintaining those steps and making sure you finish them, even if it's with a precaster you've worked with for several years on several different projects, will help you maintain and ensure that you get the right product on site when it arrives, and the color's right and the texture's right, and everybody knows what's showing up. For structural precast, which is just the gray concrete that we ship, it's kind of logistics on site is going to be your key, right? Especially in big projects where you might have multiple trades on site in part of the building while the rest of the building is getting erected, to make sure everybody knows how it's going together, where people are going to be when the crane is swinging precast pieces, and what the requirements are for the precast erector in terms of his schedule, piece rates, so that you can maintain the schedule behind the erection of the precast and maintain the precast direction as well.
Excellent. Yeah, you've got a wealth of knowledge here, that's for sure. For our audience, it'd be great to see your comments below. In what ways do you implement best practices for designing these precast elements? Chad, last question is around contract review and dispute resolution. What are some of the common issues that come up with precast and pre-stressed construction projects, and how do you avoid those and make sure that the project goes smoothly?
Well, the biggest thing for us we see is scope, is understanding the scope of the precaster, and making sure that that scope actually carries over to the contract. One of the biggest things we see is that some of the contractors who don't use precast too often just kind of consider us like another subcontractor on the job site. And we're kind of in a niche market. There's not a whole lot of trades out there that can engineer, supply, and put up a building. So our requirements are a little bit different. There's some things that the contractor has to be involved with the precast industry to understand, how the panels are going to get tilted up on the job site, how the cranes are coming in, how the trucks are coming in, and also who's designing what on the building. So having that good scope definition is a key part of the contract, and a lot of that has to be done face to face. It gets too complicated with emails to try and figure out the ins and outs of the scope contract. And the other thing is going to be just general site requirements, right? Different regions in the country have different laws, if you will, for what the contractor has to provide versus what the precaster has to provide. So sitting down with the person who's going to be running the project on site, again, face to face, and understanding what the requirements are on both ends is key to making sure that the contract is written correctly.
Excellent. Well, Chad, it sounds a lot more complicated than Lego for adults, but we appreciate you coming in here and demystifying it for us. So thanks for being on the show.
Hey, I've really enjoyed it. Thank you very much.
All right, take care.
Yep.
For our viewers, don't forget to like and subscribe, and we'll see you next time. Thanks.